All right. What is an acid or a base? There are a number of definitions, and we're going to run through them now, so it all depends on what type of definition we're looking at. The definition you would know from grade 11 is the Arrhenius model of acids and bases. Um, it says that an acid gives off an H plus ion in water, like HCl. I drop HCl into water, I get the H coming off and joining up with the water, so I get H3O plus, and I get Cl minus. And an Arrhenius base, it dissociates in water to give me OH minus ions, and NaOH is the classic example. This is in your wheelhouse right here. This is your definition, right? But it's not great. Why? Uh, because it only applies when water is used as the solvent, and water will not always be the thing that I'm dissolving things in. There's a number of different solvents that people use in chemistry, and water is just one of them. You usually want to pick a solvent that's not going to become part of the reactions that you want to take place, and sometimes water does become part of the reactions that are taking place, and you don't want that, so you have to pick a different solvent. So, uh, Arrhenius theory, only water. So Bronsted-Lowry, he he came up with a more general term. He said that an acid is donates a hydrogen ion or a proton, yes, and a base accepts a proton or a hydrogen atom, yes. So we get acids are proton donors, bases are proton acceptors. So let's take a look here. I've got NH3 and H2O. Uh, H comes off of the H2O, moves over here. I get H0 plus, OH minus. Um, Currently, when I look at what happens here, this thing is giving up an H plus, so it must be an acid. And this thing is accepting an H plus, so it must be a base. And then on this side, you see we call them acids and bases, and then we've got a conjugate acid, and we get a pair here. These guys are linked together. They differ by an H plus. We call this is the base, and this is its conjugate acid. And then there's another pair between these two guys. We've got an acid and its conjugate base. And again, notice that in both pairs, they differ by an H plus. In both pairs, they differ by an H plus. Okay? Here's another example. I've got HCl into water. I get H3O plus and Cl minus. HCl is giving up an H plus to water here. So if this is giving it up, it's the acid. This is accepting it, it's the base. And we get pairs again. Yes. I need to get rid of that guy. Here's one pair. Yes, they differ by an H plus. Here's the other pair. They differ by an H plus. Again, it's a conjugate acid-base pair. You will be asked to do that on a test. And notice here, interesting thing, here water is acting like an acid, here it's acting like a base. It can be both. Okay? And note that this definition works with the Bronsted-Lowry. Yes, HCl, still an acid, right? The definition has been slightly modified. Nothing's changed. Okay? So another definition, a Lewis acid is a substance that can accept a pair of electrons to form a covalent bond, and a base can donate a pair of electrons to form a covalent bond. And so I guess an example of this would be, let's try HCl plus that H2O, giving me H3O plus and a Cl minus. An H plus comes off of this, yes, and a Cl minus, true, and this H plus joins up here, yes, to make this guy. The H2O is donating a pair of electrons so that these two things can bond together. So this is a base. it is giving up this guy's got no electrons to bond with. Got nothing. Okay? So both electrons are coming from this guy. It's a base. This is an acid. And so it's another one that it's another definition that we use. Another thing here that we should be careful of, this H3O plus. Okay? It's called hydronium, and it's always around. You will never see me write, even though I kind of wrote it here, but not really. You will never see me write something like HCl does this, H plus Cl minus. Never, never. Because H plus in water doesn't exist. HCl in water, the H plus will always buddy up to a water molecule. When will it buddy up to a water molecule? Always. Yes. So this hydronium ion is very important, and it will, anytime we write a reaction like this, we'll always include water. We won't. This is garbage right here. Gone. Okay. So just some definitions. Keep in mind, I'm going to ask you to identify the conjugate acid-base pairs, just like in this question, and you're going to need to know these definitions for tests also.